Okay, in this class we will discuss about the random process. Uh, we have already seen what is a random variable. In the random variable, we have defined it is a function that maps the sample space points on the real axis. Okay. Random process is a similar extension of the random variable in which the outcomes of the sample space they are not mapped to the real axis, rather they are mapped to a set of functions. Okay, so suppose like in this case you have sample space outcome zeta1, zeta2 up to zeta n. So each outcome is mapped, is assigned basically a real value. Okay, that is what is a random variable x. Now corresponding to each outcome of the sample space, if I assign a waveform, okay, corresponding to zeta1, I get one waveform which I write as x of a zeta1. And if I map x zeta2, second outcome, to another waveform, this is x of t of zeta2 and so on. So this is what is called as a random process. Okay. So the mapping is not from the sample space to the real axis, but the mapping is from the sample space to a set of functions of time. Okay. This is what we call as a random process. Now, see, to suppose give an example of the random process, like if you measure the temperature of a city for a particular day and you get some continuous readings, you note it down. Okay, so you get a complete signal x of e comma zeta1 where zeta1 may represent the d1. Okay, so on one day you measure the temperature of the signal, temperature of the city continuously. So you plot it as a function of time, the temperature as a function of time, you get one waveform. Okay. Similarly, if you repeat this experiment over and over again, okay, on the second day you do the same experiment, you again measure the temperature of the city continuously. So you get another waveform xt of zeta2. This is for maybe where zeta1 represents day 1, zeta2 represents day 2, and you can have this, you can repeat this process quite large number of times. So x of t comma zeta n and so on. Okay, so this collection of functions, that is what basically we call it as random process. Okay, and the collection of all the possible waveforms, we call it as ensemble. And in this ensemble, if you take a particular waveform, we call it as a sample function. So this is a sample function. Of course, this is also a sample function. This is also a sample function. Any particular waveform in this random process, that is a sample function, and the set of all the possible waveforms, that is what is called as an ensemble of the random process. Okay. Another example I can take, suppose if you record some signal for some time, maybe for 10 seconds. Okay, suppose your speech signal. You record speech signals for 10 seconds. So between 0 to, so you take time from 0 to 10 seconds. we get some function. Okay, x function of time, we get one waveform. If you record it for another 10 seconds, you get another waveform for another 10 seconds. Okay, that measurement may be done at on a different day or at a different time, but the duration is same. And even if you try to speak the same words, okay, the waveforms that you will get every time, they are random, they are not exactly same. That is basically what is a random process. Okay, so every time you measure your speech and you try to say repeat the same words, okay, suppose I say this is a random process and I record this sound for 10 seconds using a microphone, I will get some signal, and then after some time I record the same words. This is a random process again for 10 seconds. This time the waveform will be different. Okay, so that is what is the random process. So the random process means the outcome of the trial or the experiment, you cannot predict it unless and until the process happens. Okay, so how the signal is going to evolve in time, that is basically that cannot be predicted in a random process. Okay, but yes, once the experiment is performed, is once the measurement is done, then definitely there is no randomness. Okay, means the sample functions that you have, they are not basically random. Okay, so what is the randomness? The randomness is associated with that once you measure this, once you have performed this trial, so you are not certain that which one of these sample processes will appear as the outcome. Okay, so every time I go on recording my speech, every time I will be having different signals. In some cases, maybe I will get the same. Okay, so the set of all these possible outcomes, that is what is my ensemble. Okay, and if you take a particular waveform in this, we call it a sample function. So the randomness is in the sense that any one of these possible outcomes can happen. Okay.